7, 6, 5, 4, 3, 2.
You're the boss, you're the big, hairy boss.
Oh, I'm feeling good today, Mikey. Yeah.
Whoa! Attaboy, another dog coming right up.
You're still behind, Randall. You know, maybe I should realign the screen intake
Just
valve.
get me another door!
Ah, the door, yes, door.
Well, Jerry, what's the damage so far?
We may actually make our quota today, sir.
First time in a month.
What happened?
The kid almost touched me. She got this close to me.
She wasn't scared of you? She was only 6!
I could have been dead. I could have died.
Keep it together, man.
Hey, we got a dead door over here!
We're coming! Look out!
It's common for children to believe that the creaks in their house and the howling of the wind at night are actually monsters hiding under their bed or in their closets, waiting to jump out and scare them. In Pixar's Monsters, Inc. and Monsters University, though, this idea is taken literally, and the story of monsters is retold, but from the monster's point of view. Here, the reason why monsters jump out and scare the children is because the monsters need to collect the children's screams for energy to power the city of Monstropolis. I've never encountered Sully or Mike Wazowski in my childhood, probably all for the best, but this means that I was never able to ask what exactly the mechanism for scream energy is. The idea of having energy produced by sound, though, is one that may have some sound scientific basis.
With energy such a critical resource, we're constantly investigating and inventing new means of harnessing energy from the world around us, whether by sun, wind, or water. As scientists have probably discovered, though, scream energy is one that we can rule out as a viable option for our near future.
The two determinants of the quality of sound are frequency and amplitude. If an object is vibrating quickly, it has a higher pitch and a shorter wavelength. On the other hand, or claw, if it is vibrating more slowly, the wavelength has a lower frequency and longer wavelength, emitting a more low-pitched sound. This quality is measured in the units of hertz, with more hertz indicating higher pitches.
Two researchers from Korea have been looking into technology that can convert the sound of our speech into electricity power for our cell phones. It still has a long way to go. A normal conversation produces a sound about 60 to 70 decibels. Although a cell phone operates using only a few volts, the researchers' best results have only been able to produce 50 millivolts, with a sound of research in 100 decibels. This is about the loudness of a car horn. So unfortunately, whatever technology monsters have invented to convert the sound of screams into powerful amounts of energy seems to be beyond our research for now. If you find a monster in your closet, maybe you can have some further details for our research.
If the sound wave is larger in height, it has greater amplitude and therefore a louder sound. If the sound wave is smaller in height, it has lower amplitude and a quieter sound. This quality is measured in decibels, which provides quantitative values for how the human ear perceives sound. Sound carries energy because it can do work, exerting pressure on the medium it travels through and causing compressions and rarefactions in it. All the energy produced by sound is mechanical energy because there is no chemical change in the wave, and the wave is not contained in discrete particles of energy. Scientists have long since developed techniques to convert mechanical energy into electrical energy. From these mechanisms, we can generate energy from wind or water flow. The most common way of producing energy from water is by building a dam on a river to store water in a reservoir. When water is released from the reservoir, It spins a turbine, which then activates a generator to produce electricity. Other hydroelectric power plants may simply use a small canal to channel river water through a turbine, making hydropower. In this manner, the kinetic energy of the moving water is converted into electricity. Unlike water, though, sound produces movement on a much smaller scale than a massive flowing river. The energy generated by sound is so small that scientists prefer to measure it in terms of pressure and intensity, pascals and decibels, rather than the traditional energy measurement of joules.